just the obvious. KSP is the solubility product. You calculate it the same way you would calculate, I'll call it all the other stuff we've been doing, which is the equilibrium, which is products of a reactants. The only difference is when you do this, I'll break it down. Okay, this is stuff we've done. Now the obvious is KSP is another fancy way of saying at equilibrium for a solid. Ka, Kb is at equilibrium for acid, weak acids. K equilibrium is for gases, so it's all the same concept, which is KSP is equal products over reactants. The difference is solids are never counted, right? So that's why KSP, and I'm just trying to get everybody, this is always equal to 1. So the basic reaction in regards to equilibrium is just the product side. And again, just to refresh, just like we did before, the coefficient becomes the exponent. Right? So when they use the word expression, that's the generic expression with the elements identified. Okay? So what this means is exactly that. It's going to be Ag plus squared C2O4 minus 2. Now look at how they have the formats of these. They have them so a little bit of everywhere. Which one is matches up with this?
D.
Okay. Why is E wrong?
It has a 2
In front, right, because it's going to be inside. It's going to be at the exponent level. The other thing is, why is A wrong?
Ag doesn't have a 2 plus charge.
That's right. And at least at the level we're doing, we are not going to have any more complex than it breaking into 2 parts. The 2 parts it breaks into is always going to be the positive ion, and the rest is the polyatomic. Students get messed up and they think this has to be broken up too. But just think about it this way. When you're doing it, draw a line through here. This is the positive, and the rest is going to be the negative. Could be 5 things, it will all be negative because these are all polyatomics. The reason I say to do it this way is that way you don't have to memorize the polyatomic table. You need to ask Dr. Ease if, well, in this case you won't have to worry about it, if you need to have the polyatomic table available. But that is the generic expression, okay? Now, let me now talk about the ice expression, all right? And again, I'm not going to bore you with this stuff, meaning I expect you to know that already. And this is always X'd out because it's never going to be part of the ice. I'm assuming that's what she said too.
Yeah, it's not. It isn't.
Okay, same thing. At the beginning, what's this going to be?
0. 0.
Why?
Because it's not there at the beginning.
It hasn't broken up yet. We still have it. It's like here. Here it is. We haven't done anything with it. As soon as we put it in a water or something, it's going to break apart. So this is going to be 0. Then these are going to be, and again, just to refresh, equilibrium is equal to I plus C. So the KSP for this is going to be here's the thing that gets everybody. Does everybody see why that's 2x?
There's 2 moles of it.
And more important, this is what it shows, right?
Yeah.
So, and you know it's going to be raised to the exponent. Everybody good? Okay. So I'm going to give you one to try. like everybody to do two things. Break this up into its individual components and also write the, I'll call it the general solubility product of this. That way I'll know if everybody's got this. What is it? Yeah, live on the edge, come on.
Is it 3Al positive plus OH?
No, it's gonna be this. Al plus 3 plus 3OH, remember. And there's no problem, I need everybody to answer some of these questions because I want to make all the possible mistakes here before the test. Do you understand why?
It's because it's plus 3, right?
Don't even, you're overthinking it. You always go with the subscript. So this is, what's the subscript here? It's 1, right?
Oh, yeah, and then, wait, yeah, so that goes back across, so Al is to the positive 3.
Right.
Okay, so it's opposite of, what's the
You're
point?
doing the crisscross?
Yeah.
But remember, just don't even make it more difficult than this. Crisscross will give you the right charges.
Right.
To get the right numbers, it's always going to be this subscript. Okay. Okay. What's the generic KSP look like?
It's gonna be AL3 and OH to the third power.
Okay. Now, because the stuff is Scantron based, you won't probably get hit for whether you have the minus sign or the plus sign. Okay. Because I'm assuming this test is going to be Scantron based.
Yes.
Yeah, so we don't have to get, otherwise other instructors, if you have to write it out, will be really fussy about whether it's a plus or minus the charge. Okay, now convert this into the ice format for me.
Well, the initial charges for aluminum and hydroxide are 0. Aluminum is,
Okay. Okay, you're one step ahead. That's all right, that's good. 0, 0. This is going to be aluminum. It's going to be OH. What's the next one?
then aluminum is X because there's no coefficient in the original
Okay.
equation. And then OH is going to be 3X because there's a coefficient of 3 in front of it. And then when you add everything up, X and 3X.
Okay, so what's it going to look like when we put it in here for the generic?
KSP is equal to X times 3X cubed.
Okay. Okay. Everybody see that? Okay. Now you're going to say this is pretty straightforward, pretty easy. The biggest problem with these things is when you're going to try to do the 4th root or the 5th root in your calculator to try to get these values. Okay? Setting it up isn't hard. It's when they give you the KSP and they ask you what's the concentration of this or that. Okay? So let's go to a couple of problems that she has. There it is. Did I erase this thing? Excellent. Okay, we'll do 12. KSP for PbCl2 equals 1.7 times 10 to the minus 5th. Another piece of information. If you are sloppy about putting parentheses around your numbers, when you do these things in your calculator, and if you miss a parentheses, because these are all small negative numbers, there's a good chance it'll go berserk on you. And it depends whose kind of calculator. Every calculator software is different. Okay, so it's just, if you don't get the right answer, you need to set it up right. I can't stress enough, you know me, I'm big on parentheses around everything you put in. Okay, so now, let's do the ice. Did I do it right? You gotta keep me honest too on this deal.
what I got.
Excellent. What I'd like everybody to do, what is the solubility of PbCl2? Okay? Does anybody know what they mean? What value are you trying to find? Is it here, here, or here? For the solubility of PbCl2. Right here, right? Okay, remember the following. This is always considered X, all right? Then this dissociates into its respective parts. So if you can get the concentration of Pb, right? You got this one. I don't know, is that how she explained it?
We didn't do
We
an
didn't do
example
that.
given the solubility product. We did an example given, like what you plug in for X, so.
Okay, so we'll good. Then I'm moving it to perfect. Does everybody understand what I'm talking about? Remember, this is breaking itself apart. And remember when we earlier on when we did dissolution of salts into their basic components, you know, the two. This would always be, I'll call it the parent, two siblings, that kind of thing. So what I'd like everybody to do is use your calculator and get X for me. And in this case, I'd like everybody to do it because I want to see who doesn't get it right. And if everybody gets it right, then we're good. And I need two answers to match up because I have no idea what the answer should be.
So the answer, they're asking for X, is what that question is asking.
Right, now if they ask you what the solubility of chlorine is,
They're asking for 2X.
you got it. Because that's how they'll do these future questions. She'll give you a generic and then she may say, what's the concentration of chlorine? And remember, all this information is moles per liter. Later on, you're going to get problems in which they're going to give you the grams of something, and you can't do anything until you put it into moles per liter. So the first step, I blow this up, and I have X times 4X squared. Does everybody agree with that one? Okay. Then I got 1.7 times 10 to the minus 5 is equal to 4X cubed. Everybody still good? Then divide both sides by 4 to get X cubed. Okay, before we go any further, how many people try to put that in their calculator without getting a number?
Oh, I just messed up on the 4x squared part.
Okay, good enough, that's one. How about you folks back there?
Yeah, I was on the 4x squared, or 4x. Yeah, I didn't combine them at first, with the 4x squared and the x I did.
That make sense?
Yeah, now it makes sense, because now I'm trying to.
Yeah, I can't get anybody on not putting in their calculator right, my day is not made yet. How about back there, did you get yours? Did you get?
Yeah, it was the 4X.
Okay, so everybody got tripped up on this one, it looks like.
Yeah.
You did all the hard part. Okay, and that's the problem when you're doing these. You get so used to forgetting that anything inside there has got to be squared or cubed or whatever. And the probability of that happening, 10%. So you need to be really close attention. Everything else good? Okay, I'll erase it. Okay, in the test, especially since this one is going to be a take-home, she may do that to you and not tell you what it is, so when in doubt, Dr. Google. Okay, now that I know this, what I want everybody to do, without any help from me, finish that problem off. Again, it's to calculate the concentration of iodide ion. So what we're asking is this. So I'd like everybody to do that. Iodate, right? So,
Okay, so we're solving for the two X.
you got it right. Yeah, I didn't put anything in there because I'm just, as you know me, the more confident I get in it, the more difficult I'll let you, the more work you'll do for me, I don't have to do anything. For her practice test, or you're gonna get, check with her to make sure she's not gonna hold you responsible for quadratic since it's a take-home. That's just an FYI, you can ask her on Thursday. That's why I'm highlighting this, because when you get your value, you're gonna have to multiply it by 2 for X. Okay, did you get it?
I got the answer.
What'd you
It's
get?
not up there, so it's not right.
Let's put it out there. What do you got? It won't be the first time this is wrong. What do you?
For my X value, I got 2.74 times 10 to the negative fifth. So then when I doubled that, I got 547 times 10 to the negative fifth, which is not consistent.
Okay, let's see, anybody else get an answer? Let's see what happens. What'd you get?
For my X, I got 7.2 times 10 to the negative 4.
7.2 times 10 to the negative 4, and 2x.
And then 1.4 times 10 to the negative 3.
Okay. Are you trying to do yours in decimal or in scientific?
And so,
Okay, it's important that people try to keep it in scientific, because during the test, or any test, if you just miss one decimal in your count. So I recommend strongly that everybody do these problems in scientific. Okay, let's see who else. Let's see, 1.4. Okay, that's a possible. What'd you get?
I'm still working on it.
Pardon?
I'm still working on it.
Okay,
I
that's
kept
okay.
getting the different answers every
That's
time.
all right.
I can figure it out.
Okay. How about you back there? Did you get it? Set up, or just this answer? Blanked out, okay.
Yeah.
Okay, did you try to set it up?
I don't even know where to begin.
Okay, remember, ice it.
Yeah. I
What'd you
iced
get?
it.
What'd you get when you iced it?
X and 2X.
Okay, so KSP is equal to X times 2X squared, right? Okay, go shoot, and we know the KSP is 1.5, right?
Yeah.
Okay. And we know this is 4X
Wait.
cubed.
How do we know KSP is 1.5?
It's given.
We're doing 16.
Oh, I was looking at 17. That's why I was like.
Oh, no wonder you're, okay, good enough. Then you know how to do this, because I know you know how to do it.
Okay, yeah.
Okay, good enough. I know you know how to do it. I just was, so I kept on looking at you and say, what, come on, you did the last one.
Yeah, that's why I was like.
Did everybody get this answer? Anybody not get this answer? But now you got it, right?
9.
Okay, you're gonna get there. You got it?
Yeah, got it.
Okay. Again, pretty straightforward stuff once you start. But a lot of you, mark my words, are not gonna use the ice tables. You're gonna do it in your head, and you're gonna muck it up. Put it in the ice table, because otherwise that 2x will get lost. You'll just square it. So, I mean, obviously you can do what you want, but that's, if you ask me, where do I see the most common errors? It's there. And you should have your KSP values. If you don't, and it's not in the book, you know what to do. Okay? Check with Google. All right, I'll erase this thing. Okay, you got it?
Yeah.
Okay. Okay, now we're gonna make this a little more difficult. Problem 17. Okay? Okay. Okay, remember, KSP is based on moles per liter, so when she gives you milligrams per liter, you're gonna have to do some conversion. But before we even get to that, what does this break down to?
I got BA to +3, +3 CO minus.
Okay. How many people got that way? Remember I said polyatomic? So overthinking it. I'm gonna do this. This has nothing to do with,
Oh, right, okay.
you wanna do this. First step, break it in half. The first element will always be positive. The rest is always gonna be negative, no matter how many iterations. I'd say about 10 to 15% of the students will do that on the test. And you're not alone, and that's why we catch it here, so then you just say. So, now we break it, what's this gonna be?
Yeah, BA plus.
Plus what? 1, 2, or 3?
One.
Why?
Because if the 3 is part of the polyatomic, that means it's going to be 100%.
Okay, okay. One little trick, if you, how do you know what BA is? You go into your periodic table, and it's group 2, so it's gonna be +2. So, in case you don't remember, if it's in group 1, it's +1, group 2, it's +2, okay? Again, I don't see the person taking off, but here's what I see happen. Suppose they ask you for the generic. All right, and then put plus, you put +1, CO3. So whenever you're getting one of these, remember, group 1 and group 2, +1, +2, polyatomics, that'll be off your cheat sheet. So that's the first thing, okay? Okay. KSP, it's gonna be, I'm cheating now, I'm just gonna go right to the KSP and not do ice. Does everybody agree with me with that? Okay, now, how do we get the information? This is milligrams per liter. I need to get it into moles per liter. So we don't have to do anything with the bottom because everything's in liters, but what do we have to do on the top? Well, let's try this. This is a memory refresh.
You'd have to define it by the molar mass.
Right. Again, refresh. A mole is equal to grams divided by molar mass. Okay? We have the grams. Okay? We can calculate the molar mass by going into the periodic table. Okay? But this is milligrams, so before we do anything, we got to convert it to grams. Why grams? Because then you can go to moles. You can do it this way, but let's make it a little easier. We know that 1 gram is 1,000 milligrams. Once you get into grams per liter, you can convert it immediately into moles per liter. So once you folks do that, see what kind of an answer we get for the moles per liter, which is going to be the X value. So just need everybody to do something. The answer? Yeah, it could be -5, -4, -3. Yeah, remember, whatever the answer is going to be small because you only have 14.8 milligrams, so you're going to divide 14.8, 5,000. Then you're going to go and then divide that by the molar mass. So you're going to have some small numbers. The reason I want everyone to try it is this is where we make errors. It's straightforward, but again, I can't tell you how many people make errors on this. Right. So it's going to be, let me see, we don't know what it is because we're trying to find it. That's the question. Number 17. Right, and then, once we find the x value, we square it, and that'll give us the KSP value.
How do we get the atomic mass for the polyatomic ion?
You gotta look up the periodic table and go in the individual elements.
Okay, so it would be like carbon and then oxygen times 3, and you add all those up together?
And barium, one carbon.
Okay, so we're not doing the solution part, we're doing the reactant. We're dividing by
Yeah,
that
because
whole mass.
the key word, KSP value for BaCO3.
Okay.
So it's gonna be the entire. And this you're gonna get off the periodic table. What'd you get for, anybody got, what's the molar mass of BaCO3?
I got 203.3.
197.
What'd you get?
197.
What's that? 197.
I don't know, I got 203, I must have counted wrong.
Yeah, if you're outvoted, something happened.
Yeah.
Okay.
Yeah, I had one too many oxygens.
Again, it's simple stuff, but I think better vertically, so I always do this. Times that, times the number. That just makes it easier for me not to make as many mistakes. You get it, What'd you get?
I got, oh wait, for everything,
Yeah.
for moles, I got 7.5 times 10 to the negative fifth.
7.5 times 10 to the negative fifth, that's x?
That's the number of moles.
Which would be this, right? And then you squared it?
Yeah, that's right.
Okay. How many people got that number? Okay, we're good.
Yep.
What'd you get? 5.6 times 10 to the negative.
9.
Okay, that feels good. Is that one of the answers?
Yes.
I feels even better. Good?
Yep.
Are you good?
How do you get 5.6?
Did you get this value?
Yeah.
Go back to the original equation. Remember, it's x times x because KSP. You didn't ice, did you?
So I have to square it.
Fine, yeah. You good? Where's the problem?
I guess where did we put the 197?
Okay.
What did we use that for?
We did that to calculate the number of moles.
Oh,
Got it? Okay.
so then it was.
It's gonna be the, you gotta convert.
0.0148.
I don't know exactly, but what'd you get, 0.0148
Mhm.
divided by,
The 197.
by 97?
The 197.
Is that what you got?
Mhm. Well,
Yeah, that gives us the moles.
I gotcha.
Okay, good enough. Again, a lot of this is just trying to refresh yourself on moles and liters and all that stuff, so. Everybody good? Okay, let me erase this thing. Okay. I think right now we've twisted the KSP problems in all kinds of versions. We got them where we have the KSP, we gotta find the concentration. We have the concentration, we gotta find the KSP. So I think we're in good shape. Now let me move this to something that I don't know. Has she talked about common ion effect yet?
No.
Oh, no, that's a different one. Let me do common ion because that falls better from a teaching standpoint. Okay, let me try this one. Before we do that, 15. Okay, so I'm gonna just write down some numbers. Okay, I'm just gonna make up some stuff for 15. I'll make my own number. Okay, before we go into this, the question is, which one of the following salts has the highest solubility? Okay. What does the highest solubility mean in your mind?
Most soluble?
Most, what did you say, most soluble?
Most soluble.
Right, so it's gonna be the one that's gonna dissolve the most, right? Okay, if you looked at these three, which one is gonna be the highest solubility?
The one with the lowest KSP?
When you say the biggest number, the biggest this, or the biggest that? Yep. But think about it. If you're not sure, which one in your opinion is gonna be the highest solubility?
In my opinion, the highest solubility would be 6 times 10 to the negative 5, because I think it's the lowest KSP, isn't it?
No, be careful now. Let's take this and put these in decimal points, okay? Right? So which one of these numbers is the biggest?
The biggest would be the 3 times 10 to the negative 3.
Right, and that's gonna be the most concentrated, right?
Yeah.
So, you see how you get confused by these things?
Well, that's not what was confusing me. I thought that the smaller number was the most soluble, because that's how it was in the last
Oh,
lesson.
okay. When you said the smallest number, I wasn't, you meant the smallest negative.
No, overall, the smallest is what I meant.
Okay.
I had it reversed. You're saying that the largest KSP is going to be the most soluble, correct?
You could say it that way, yeah.
Okay, because I was thinking it was the lowest. That's what my issue was.
You could say that. Okay, the largest KSP, which is gonna be the most concentrated. Does everybody see this? It's counterintuitive, that's why I'm trying to,
So the largest KSP is the most concentrated, so it's the most soluble.
right. Or the smallest negative, right?
It's easier just to think about the overall.
Yep. No, that's, and the least soluble is gonna be this one. Everybody good?
Can you say that one more time?
Sure. The smallest negative number is going to be the most soluble because you can see this is bigger than any of these other numbers.
So the number with the greatest value is the most soluble,
Greatest value, in your mind, what's the greatest value mean?
the biggest number.
Okay, and that's this one, right?
Yes, the number that has the most effect.
Yep, and we didn't say the largest value. I wanted to make sure we didn't get caught up in the minuses, because that's where everybody gets caught up. Folks are getting lucky, don't smile. I think you take this picture.
If you smile, I'll be out of here faster.
I'm lucky I'm not blushing.
You can keep teaching.
Enjoy yourselves. Okay, meanwhile, so when we go back over here, which one of these is going to be the most soluble? Highest solubility?
3.6 times 10 to the negative 8.
1.7 times 10 to the negative 6.
Oh, I didn't see the 6.
Okay, that's my poor writing, so it's not you. Okay,
Okay, so the value that is the most soluble has the biggest KSP.
when you say the biggest
The
KSP,
biggest KSP, so when we remove all of the exponents and put them in straight decimal form, the biggest number is the highest KSP, which is the most soluble.
Which
So
is gonna be-
it's 1.7 times 10
okay.
to the negative 6.
Is that, as long as that works, because other people say differently, okay?
Okay, so if all of those numbers were not negative, if they were positive exponents, the biggest would be 1.2 times 10 to the negative, or to the 12.
You got it.
Okay.
Okay, now, does everybody think they got it? Let me give you the quiz. Okay. One more thing. Okay. Of these three KSP values, which one of these is the highest solubility?
6.0 times 10 to the
Okay,
negative
because
4.
that's what happens sometimes, okay? She won't give you the easy one, she'll give you one where it's 1.5, 2.5, and you gotta do two things, you gotta go into here first, and then come back. Okay, so I just want to do that, and let me do the common line, and you folks can get the heck out of here, all right? Because she hasn't done a common line, but that's good for you, and this is called a common ion problem. Why is it called a common ion problem? It's because you notice that there's two solutions in there, right? All the other stuff we've been working with has been in water, right? Okay, so you see, you see that? Does everybody see that? So when we draw the ice for this, okay, that's what the ice. Exactly. This time it's not 0. It's going to be, because imagine again, they're putting this into not a solution of water. They're putting this into a solution that has fluoride ions, right? So the initial concentration, we ice it. Yeah, this doesn't count. Does everybody see why that is that number? Got it?
Because it's so we only put the point on as.
We only put the
value.
keyword, the common ion. What's the common ion?
Fluoride.
Fluoride. If they had said lead nitrate, say the solution was 0.10, then you would be putting it here. So the key thing is a common ion effect. And all common ion effect is just doing the same problem, but now your ice value initially is going to have some numbers. Yes?
The 2 in front of like the four, yeah, that doesn't have any effect with the 0.1 at all. It wouldn't be 0.2 there.
It doesn't have any effect right now. Okay, I'll
Okay.
show you the rest, okay? Because this is what's here, okay? So as we, okay, what do I put here?
X.
And over here?
2x.
Got it. So what does this look like here?
X.
And 0.1 plus 2x, right? Okay, Dr. Eads is going to tell you that she's not going to worry about this because this is going to be so small in comparison to this that when you do your KSP, you don't have to worry about it, okay? Okay, so what I mean by that is 3.6 times 10 to the minus 8 is equal to x times 0.1. She will tell you there's reasons for this, which we're not going to get into, but yes, very good. Good catch. I got sloppy, didn't I? Did everybody see why it's squared?
Because it has a 2 coefficient on it.
You got it. What I just did is a typical mistake students make. I make it. So it's a typical mistake where they just put it, they just get so excited they get 0.1 and they forget that it's going to be squared. Okay? Solve for x. What do we get when we solve for x?
3.6 times 10 to the negative 6.
That sounds good. Everybody else got that?
I got that.
Fun?
I got that.
Okay, now, what's the question? They want it in grams per liter, so what are we gonna do? We gotta get the molar mass of PdF2 and multiply that. Because, remember, this is moles per liter. We want to go to grams per liter, so we have to cancel this. And somebody can tell me what answer they get, I'll be really happy. And I'll be even happier if it's one of the answers there.
2.1 times 5 to 10. Oh yeah, that's okay. 8.1 times 10 to the negative 4.
-4?
Yep.
Okay.
That's what I got also.
Okay, do you see how tricky these are gonna get? If she gives you a scantron, they're gonna be within units, and so if you make one simple error. So these problems aren't that bad, they call them common ion. Just remember when it's common ion. Now, where it gets complicated, and we won't do it this time, but maybe next time, is if they go into asking for how to create a precipitate.
Yes. Where did we get the 8.8 times 10 to the negative 4 from?
I'm assuming,
That's when you move it from moles to grams.
right here, okay?
Oh, okay.
In other words, 1 mole is equal, and I'm assuming this is what was PdF2?
It was 245.
Okay, so it's gonna be times 245.2?
Yeah.
Okay, that's how you get that, okay?
Oh, okay.
I might post this, depends how disjointed I get. Any other questions on this thing? It's important, the most difficult problem in this whole menagerie, the others are all careless, is gonna be determining precipitate when she gives you 2 different concentrations. I'm not sure how to do it, and it's gonna be definitely on your wish. And if you're not sure how to do it, come in here, or we can go over it next Tuesday. Okay, everybody, thank you very much.